Hi there, Dr. Artilin speaking. In the video, I will do the program coding for CMA from TAIROA for the robotics engineer certification. So at this moment, please change the file CMA as R plus test ID. For example, the test ID is 12328. Okay, and then you should change. You should make to a coordinate, and in the Z direction you type 174. It's for the end effector. Then you open the file. So in the file you will find the simulation command lines. Please change the simulation as main for the main program, and then add a remark line and type sub. It means for subroutine area. And then following is to define the subroutine. This subroutine is used for simulation, and I will name the subroutine as sim, and type enter at the bottom of the program to make the subroutine structure. And we have input parameter code, and I declare the code as an integer, and we use the switch code case. And the switch is the structure for switch. So we jump to the bottom of the program. For the case 0, it will bring out the whole table, and then scroll down, and we find the gripper, and type case 1 for grip close, and case 2 for grip open. And now please copy the line grip open, and find the table line, add the grip open under the table. Okay, now the subroutine simulation is completed, and in the main program, please call out the sim subroutine and type the code 0. You will bring out the whole table on the display. And then, according to the test regulation, we should let the gripper open and close 3 times at the beginning of the test. So I defined another subroutine 3. Here I declare an integer k parameter, and for k equals to 1 to 3, and step 1, and wait for second 0.5, and I call the simulation 1 for gripper to close, and then we call out the DO1. Here is not right. It should be pulse for 1 second. I will modify the line later, and wait for the sensors read the switch. Read the switch DN1, and here for line as a group, I will change simulation 2 and DO2. Okay, and DI2. So we completed the subroutine 3. Here I add another line P to P0. Because you call out the whole table, then you should let the gripper return to home. And however, in the simulator we don't have the line, so we must do add 4 points for the program. Yeah, here are some errors. Now I debug. So you can find the error is happen for the full structure because I didn't add the end for this structure. So now I change the pulse, for DO1 and DO2. You see, in the test, if you cannot complete the structure, then it will be difficult to find where the error is. Okay, now I correct the problem for N4 structure. Now I hook up the DI1 and the DI2 because in the program it will change these two input points for the program to run. Okay, now the initialization setup for the program now is completed by these two subroutines, simulation and 3. Again, I try this program, and now I will do the programs for the simulation. First, I define a subroutine I called where to find the points on tray A or tray C. For this subroutine, we have 3 parameters. Tray is used for A or maybe A or C tray. So I declare tray as an integer, and the K stands for where is the points for tray A or tray C, and the PK is a pointer, so I declare PK as E6 point. For this subroutine, I suppose PK is equal to P1 at first, and then I add 2 parameters LA and LC to control the G coordinate. Then for the tray A, I type 25 times LOA minus by 1. Because for the layer 1, we won't change the height of Z direction. However, if layer 2 is LOA is 2, then the answer LOA minus 1 is 1 and times 25. It should be raised to 25. Maybe LOA is 3, then LOA minus by 1 is 2. So the height will be increased to 50. Okay, following we should check the tray. If tray is equal to 3, then you should change PK to P3 because we want to find a pointer on the on the C tray. Again, we change the height of the height for the points on tray C. However, the parameters should be changed from LOA to LOC. Then we let K be K minus by 1, and we find the X and the Y position. Okay, now the subroutine is completed. So now we can find the points on tray A or tray C, and we should ask, what should we do the next step? Maybe we should construct subroutine for the gripper to pick or place. So I define the subroutine as gripper and use parameter code as integer. And for the gripper, when the robotic arm go to the point, maybe on A or C, the gripper will down 50 and then raise the 50. Okay, between these two lines, we must decide the gripper should be closed or should be open. If the code is equal to 1, then the gripper should be closed. So wait for 0.5 seconds, and then use the simulation 1 for the gripper to close. And then here I type a little bit quickly. I type for DI1 to be equal 1. However, I should type DO1 to be pulse for 1 second. Here I should type a pulse for 1 second, and I must copy these 4 lines as a group for the gripper to open, and I type here else, and I pass these 4 lines here. And now change the simulation 2 and DO2 and wait for DI2. Okay, now the subroutine for gripper is completed. Then I check, yeah, there's something wrong. Because you see I type code as CDOE. Now I changed to COD. Now debug again, you will find everything is fine. Z50. Okay, clear. And then debug again. Okay, now there is no bug in the program. And finally, I will define the last subroutine. I will call it run. Here. Then I will define the subroutine run. For the run subroutine, I use the two parameters J and K. J stands for a point on tray A and K for the point on tray C. So I declare J and K as integer parameters. Okay, now I type where for tray A and J point, and this subroutine where we will find the point position, and the PP is the intermediate point. It only will be used in the subroutine. I use the where to find a point on tray A, then I P2P PP. Then I go to the point on A, I will pick the workpiece on A, and then I P2PP to P2, and I use the grip 2 to open, to place the grip workpiece on P2, and then I return to home, wait for 3 seconds, and return to P2, and pick the workpiece again. And I will use the where to find the point on tray C. That's K points. And the PP is the the intermediate point. Then I find the position on tray C and P2P PP. Then I will place the workpiece on tray C. Okay, I use 2. Then P2P P0, return to home. Now all the subroutines are completed and no bugs in my subroutine actions. So now let's go to the main program area. Yeah, here I add another remark line. That means below I will do the action for theme A. Now I set LA and LC equal to 1. That means for layer 1 on tray C and tray A. And here, please do set this command line, because the maximum speed for the particle is so fast. About automatic mode, the speed is 2000 mm per second. So here we reduce the speed to 10%. Now we add a timer. Then timer stop here. 1. We won't stop the timer at this moment. However, at the last line, for the timer stop, I have a typo. It should be 0. I should be 1. However, I type time stop as 0s. So this command line should be correct. It must be equal to 1. Okay, then I test the workpiece from point 1 on tray A to point 1 on tray C. Okay, I move several, including timer, IO, and points to the left. Okay, at this moment, I remember all these 4 points are not defined, so I must define these 4 points. Yeah, now I will do point calibration for P1. Yeah, 353.5, and about the Z direction is -208 and raised to 50. Okay, now it's the point for P1, and now overwrite P1 point. The last Step I will override P3 for the correct position. And after calculation, I find only the x coordinate must be modified. It should be 4. And then I override the points for P3. And then I will correct P2 position. And the x is 331.5. And about y is 199. And the z minus 114. Okay, it matches. And then I will raise the height by a distance of 50. Now overwrite P2. Now these 3 points are corrected, P1, P2, and P3. I return the gripper to home. Then I replace P0. Now these 4 points are correct, and I finished the points calculation. Okay, now I do the test for point 1 on tray A. I will move it to point 1 on tray C. Okay, now return to home, waiting for 3 seconds, and then return to P2. And you can watch the timer is running. Yeah, the test is right. Now I will do the right actions for the theme A. I will move the first work piece on tray A to the second point on tray C, and then the second point to point 4 on tray C, and point 3 to 6 points on tray C. And for the first layer on tray C, we have 2, 4, 6, 7, and 9. And then I will change LC to the second layer and run the 6 point on tray A to the 2 point on tray C. Now 7 to 4. Run 8 to 6. And change the layer of LC to the third layer and run the last piece on tray A to the second point on tray C. Okay, the whole program is completed. Yeah, I speed up to save the time. For the test, I will run the complete program, so be patient. Be patient to watch the the operating of the robotic arms. Yeah, second point on tray A. Because I use the SanDisk to simulate the operation for theme A, however, I find there is video lagging. However, the operation is normal for the theme simulation. Yeah, I changed it to the timer table. You see the time is running. According to the test regulation, the limit time is 60 minutes. That is maybe 360 seconds, the operation time limit. Okay, now it's only 78 seconds. So after the finish of the program running, it should be under 360 seconds. Okay, now is the workpiece 5, and the time is 100 maybe 15 seconds. Okay, now is for a second layer for layer C, and the height is still keep at a good condition. So I think the time is enough for you for the examiner to finish the program coding and do the test. I think the time is enough because it is the time limit is 6 minutes, and you can see on the display now the simulation is maybe only 100 and maybe 70 seconds, and because we use the T1 mode. T1 mode we use the 100% speed. However, the maximum speed for the T1 mode is 250 millimeters per second, and in the automatic mode, including auto option or external option, the maximum speed is 2,000 millimeters per second. So if you use the 10% of the automatic mode, it not make a big difference. Now I add the ISR1 for the file, then I change the mode for external. Okay, now I find that I hook up DI1 and DI2 on, and I find the FI page, and please number 3 and number 4 please hook up. Then the file will automatically run. So I can move the I/O page to the left. I lock the icon item, and you can find on the simulator the PTP cannot have the start button disables. So I must use the I/O pages to hold the operation of the robotic system, and the timer still continue to run, and off the hold, and then it continue to run. So you do remember, for the simulator you must use the I/O page to hold the robotic arms. You cannot use the TP on the left column because the start button is disabled. However, in the real robotic table, you can use the TP to pause the operation of the robotic arms. So you may check the diagnosis and look back. You may also find the operation steps for the robotic table. Okay, start, pause, continue, pause, and you may calculate the time for your operation here. And do remember, the time should be under 6 minutes. And I think it's enough for the examinee. Thank you for today's listening.